Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Incognito by Kafka Farnham. And here are the rules. We have chaos construction rules where we need to divide the grid into 9 regions, each made of 9 orthogonally connected cells, such that each row, column, and a 9-cell region contain the digits 1 to 9 exactly once each. So to construct an orthogonally connected region, that means that in the region, to get from one cell to any other cell in the region, you should be able to stay within the region just by going through edges. So for example, if you tried to go this way to any of the other regions, you could go through the edge here, 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 here to get to there. But this is not a valid example of an orthogonally connected region because if you try to go from any of these cells to here, you could not stay in the region just by going through edges. You could go through a corner, but that's not valid as an orthogonally connected region. You could also not do something like, I don't know. You couldn't have something like here, because even though these two can connect to each other orthogonally, they can't connect to the rest of the region by staying in the same region by going through edges. So that's how chaos construction rules work. We also have the digit in the top left cell of a region. So in a region, say this was a region. In a region, the digit in the top left cell of the region is its region number. For example, okay, so we're given an example. Row 3, column 6 is a higher top level than row 4, column 1. So if we had a region like this, despite being much further to the right, and no two regions may have the same region number, such that the region numbers must form a set of digits 1 through 9. So, for example, if we had a region like this, say like this, the top left cell of the region is considered row 3, column 6 instead of row 4, column 1, because it's the leftmost cell of the top line, right? So since this is a top line, it's the leftmost cell of there. Therefore, that would be considered the top left cell of this region, and the digit in that region would be then considered the region number. And no two regions can have the same region number, so they all have to be uniquely different. So there's no repeats in the top left cell of the leftmost of the top line of each region. We also have killer, where in cages, digits must not repeat and must sum to the total indicated in the top left corner where given. So for example, these 2 digits add up to 4, these 3 add up to 6, these 6 digits add up to 23, these 7 digits add up to 28, and as an example, if this were, say, a 3, this would have to be a 7 because these 2 digits must add up to 10. And you cannot have repeats within killer cages, so remember that. And a digit in the top left cell of a cage with an indicated total is also the region number of the region it is in. With the indicated total. That means this must be the region number of the region it's in. This must be the region number of the region it's in, etc. for these. All the same for these, right? There should be 9 at most. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are. So the digit in the top left cell, so the leftmost of the top digit of the top column, top row in the cage, with an indicated total, so this one does not count, is also the region number of the region it is in. So all these cells must be the the leftmost of the top row in its region. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so let's mark all these top regions, right? Actually, let's just fill in the cages. This is 1 through 3. This has to be 1, 2, or 3 to add up to 6. This is 1, 2, and 4, adding up to 7. This is 1 through 5, adding up to 15. 5 digits uniquely adding up to 15. Therefore, we have a 1, 2, 3, 4 quadruplet in column 2, which eliminates 1 through 4 in the rest of the column. Also, this can't be 1, this can't be 1 or 3 because of the 1, 3 pair in the column. And we have a 1, 2, 3 triplet here, which eliminates 2 here. So one of these must be a 2 here. But this 1, 2, 3, 4 quadruplet in column 2 eliminates 1 through 4 in the rest of the column. Therefore, this must be a 5, which means this cannot be 5. These can't be 5. And one of these is a 4 then, because the rest of the digits in the column are 6 through 9. Since this is a 4 here, this cannot be a 4 here. So this must be 4. Sorry, this cannot be 4 here. So this must be 2, which makes this a 4. These cannot be 2 or 4 here. Sorry, this can't be 4 here. It has to contain a 2, so there's no 4 here. This cannot be 2 anymore. We have a 1, 4, 1, 4 pair, which eliminates 1 and 4 in the rest of the column. These can't be 1. This is 3. This can't be 1 or 3, so this is 2, which makes that 1, which makes this 3, which makes that a 1. Okay. We know these are separate regions because every leftmost of the top cell of a cage is also the region number of the region it is in. And that's always the top left cell of a region too. So these have to be separate regions, which means this goes this way. This is also another region, so it cannot go here. This one has to go this way. So this is a region boundary here. This is a region boundary here. This is another top left of a region. Same here and same here. So this has to be essentially... this one is the top left of another region, but this has to go down this way. So this cannot go this way. If that goes that way, it would not be the top leftmost of a region. This light can never go in here because that would make this medium gray region smaller than 9. So this has to all be medium gray, which means this is a border. This has to go this way. This means the orange has to go down because there's no other place to go. We're going to mark this as blue, this as yellow. Actually, let's make that pink, and this is yellow. So this is the top leftmost of this region, so this cannot be yellow here. It also cannot go up. This can't go up either. This blue cannot go up, and it can't go left. So this blue region has to be essentially this, because it can't, otherwise if it tried to go up, it would have a topmost region there. So we know the blue has to go this way. So this is the blue region here. This pink cannot go anywhere else this way. Can't go up. It could go here, so that's valid. This is 6 through 9 here. We have 1, 2, 3, and 4 already in the regions, in the region numbers. So this is 5 through 9. This is 5 through 9, and this is 5 through 9. But this can't be 5 because this cage adds up to 10. So 5 would have to add up with 5 to add up to 10. That's not possible. So we know one of these is a 5 here as a region number because there's no repeats. Also, where is this digit in row 9? Can't be any of the rest of the blue region, so it must be here. So this is 6, 7, 8, 9. It could 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is red or yellow here. This is red or yellow. The pink cannot 1, 2, 3, 4, 5, 6, 7, 8, and 9. It cannot block this cell because these two are the same region. This is 1 through 4 here. These are all 5 through 9 in the rest of column 1. What else do we have? This digit. Okay, say this was not 5. If this was not 5, all 4 of these digits must be unique. There cannot be repeats because there's no repeats in the region numbers. Therefore, this would never be, that would eliminate all possibilities for that cell. So this has to be a 5 here, which means this cannot be 5. This digit is the same as that one. This digit must be the same as that one then. Interesting. This is a region border. The yellow has to go down. The pink cannot go up here because this is the leftmost of the top row of that region. So this one has to be pink at least here. Therefore, this yellow has to go this way. So this is a border. This has to be a border. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. How many digits? Okay, so this yellow could go this way. How many digit cells do we have here now? 1, 2, 3, so these 3 regions have to be yellow, red, and pink. So this is yellow, red, and pink. All of these can be pink. This pink has to connect to this, so this could be yellow here. This could be pink or yellow. We don't know which. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. One of these is yellow, one of these is pink. These are all red because there's no other place for the red to go. Because we have to have 4 regions worth in here. And the red cannot go up, the yellow cannot go up, and the pink cannot go up. So this is all of a region here. This has to be yellow and red here. But this cannot be yellow. If this were yellow, that would block this from ever extending anywhere else. What else do we have? This light cannot go this way because that would be a 1, and there would be a repeat in its region. So this has to be some other region. It cannot be dark because that would block this area. Well, not true. This could actually be dark because it could extend this way. It just light didn't have enough to be able to extend here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10, 11. So this light couldn't be that. It can't be dark. It can't be orange because then that would block the dark from being a 9 length region. So this light has to go down this way, which means green has to go down here. This is a 4 then, and this is a 1. These are separate regions. This light cannot go down to the 1, so it must go this way, because otherwise there would be a repeat in that region. This is 5 through 9. This is a separate region here for the 1. These 6 digits add up to 21. The minimum amount you can have for 6 digits is 1, 2, 3, 4, 5, 6, which adds up to 21. Therefore, this must be a 6, and this has to be the digits 1 through 5. These are both yellow here. This is a 5 here. What else do we have? This cannot be 1 because of the 1 in the column. These cannot be 6. This is at minimum 15. This is 15, 16, or 17. Okay, this can't be 6. So these can't be 6, this can't be 4, this can't be 6 because of the region number restriction where they're all different ones. If this is 8, 9, that would add up to 17, and the remaining 3 digits would have to add up to 5. So this cannot have 8 and 9 here. It has to have a 7. And in fact, actually, the rest of this pink region, this is all 7, 8, 9. That means it must be 1 through 6 here. Well, we know 7 has to be one of these 2 digits, because if this is 8, 9, that would mean these 3 digits add up to 22 minus 17, which is 5. And the minimum of 3 unique digits adding up would be 1, 2, and 3, which is 6. So this is either 7, 8, which adds up to 15, or 7, 9, which adds up to 16. So this would be 6 or 7 here. Well, that must mean this is 1, 2, 3, or 1, 2, 4, which eliminates 1 and 2 in the rest of that region. We have 7 digits adding up to 28. And it has to be the minimum amount for 7 digits adding up to the sum is 1, 2, 3, 4, 5, 6, 7, which does add up to 28. So this must be 1 through 7. This can't be 1, 2, or 3. This can't be 2 or 4. Neither of these can be 1. And where are the 8 and 9 in column 9? It has to be here and here. Therefore, the 7 has to be one of these 4, which means this can't be 7 here. 7 has to be one of these 2. We already knew that. So this digit, okay, this can't be 5. We know one of 1 or 2 has to be here. The other 1 or 2 has to be here. And this is 3, 4, 6 with 3, 4, 6 here. Okay. This says 1, 2, 3, 4, 5, 6, 7 unique digits there. This is 6 digits adding up to 23. You can never have... Okay, so this digit sees both this cell and this cell. So this has to be the same as this one. So this is 8 or 9. If we try to have 9 here, Can you have 5 digits adding up to 23 minus 9, which is 14? No, because the most unique digits you can have is the minimum you can have with 1, 2, 3, 4, 5 is 15. 15 plus 9 is 24, so this can never be 9. This is 8, which forces this to be an 8, which makes this 9 and 1. So this has to be a 9 here, because the blue region doesn't have a 9 anymore. This has to be 7 and 9, so that's 16, which means the other digits must add up to 1, 2, and 3. So this can't be 3, this can't be 3, this can't be 6 because of the 6 in the column. This cannot be a 9 because it's the region number of the region. And we already have a 9, it's already a region sum. So this is 7, this is 9. This 8 must be with 1 through 5 here to add up to 15. Or sorry, 23. Well, 15 plus 8 is 23. So therefore, cannot be 1, 2, 3. This can't be 4, 5, 4, 5, 4, 5. These cannot be 2. Where's a 2 in this killer cage? It's here. So this can't be 2 here. This 3, 4, 6 matches this, and it has to be 4 or 6 specifically. So that's 4 or 6, and this is 1 or 2. And this must match this digit, so this has to be a 1 here. This can't be 1 here. Where is the 2 in this column? It has to be here. So this is 2. This cannot be 4 because of a 4-5 pair in the row. This can't be 3 because of a 1-3 pair in the row. We have a 6-7 pair in column 9, which eliminates 6 and 7 from the rest of the column. This can't be 6. This is 4, which forces this to be 5. This can't be 4 or 5 or 2. This can't be 4, 6, or 7, so this is 3, which makes this a 4, which makes that 5, which makes that 4. 1 cannot be either of these two. This 2-3 pair eliminates 2 and 3 in the rest of the cage, so this is 1, which makes this 3, which makes that 1. We have remaining a 6 and a 7 in column 8. So this is 6 or 7. This can't be 1, this can't be 1 or 5. 4 cannot be either of these. This can't be 1 because of the 1 here. So this is 3, which makes this 2, which makes that 3. This can't be 2 or 3, and a 2 or 3. The 1-5 pair eliminates 1 and 5 in the rest of the row. So this can't be 5. This can't be 5 because of this 5, and it can't be 9 here, or here, or here, or here. Okay. This is 1 or 5, and the red region already has 1 or 5, so this cannot be red. This has to be yellow. We have 1, 3, 5, and 6 already in this 21 cage, so this has to be 2 and 4 here. 2 and 4 cannot be red because we have 1 through 5 already in red, so this cannot be red. This is yellow also. So we have 4 yellows here. Sorry, 5 yellows. We have to have a 6 in one of these. And we don't know what the rest are. This can't be 9. We have 6 through 9 in the rest of row 7. And we have 2, 4, 6, 7, 8 in the rest of row 8. This 2-4 pair eliminates 2 and 4 in the rest of the column, so this can't be 2. This can't be 7 because of the 7 in the column. Okay. Regions. This gray region has to contain... this medium gray region must contain a 4. Actually, it's specifically 2, 4, 6, 7, 9, right? No 8. No 2, 6 here. No 4 here. This can't be 7 either. But this gray region has to contain 2, 4, 6, 7, 9. So this cannot be the medium gray. It can't be orange because then the dark region would be smaller than 9. The light region already has a 4. 1, 2, 3, 4, 5, 6, 7, 8, 9 cannot reach from the green. Therefore, this has to be dark. 3 cannot be... This could be... Okay, so this cannot be orange because if it's orange, we would have 4, 6, 7s in that... Sorry, 3, 6, 7s. 3 digits containing 6 or 7 in the orange region. So this cannot be orange. It has to go down then for the orange. So this is a border. What digit can this be? It cannot, medium gray cannot reach 1, 2, 3, 4, 5, 6, 7, 8, and 9. Light gray can't reach 1, 2, 3, 4, 5, 6, 7, 8, and 9. And green can't reach 1, 2, 3, 4, 5, 6, 7, 8, and 9. Or 7, 8, and 9. So this has to be dark. We also have a 6, 7 pair in row 3, which eliminates 6 and 7 in the rest of the row. So this is a 5, 8, 9 triplet here. This must be 6, 7, 8, and 9. But this can't be 6 here. We have 4, 7, 8, and 9 in the rest of column 4. We need access to a 5 for the... We need access to a 1 and access to a 5 in the medium gray. Also, the dark has to have access to a 1. The dark cannot access this way, because that would make the medium gray 8 in size at most. So this cannot be dark. Orange has to go to a 1, and if the dark goes here, that would block orange from being a 9-cell length. So this must be orange, which means this is surrounded by orange on both sides, and this can't be pink, therefore this must be orange. This 4 cannot be dark because we already have a 4 in that region. Therefore, this has to be orange. Because it cannot be light, it cannot be medium, it can't be dark, and if we tried to have a green there, this would not form a region that... This would block off this region from forming. So this has to be orange. This one has to... The dark cannot... Again, the dark cannot block off this... Cannot reach here because it would block off the medium gray region to be less than 9 cells. So it must be this one that it reaches. It can't reach this region. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has to be dark. The medium gray has to reach a 1. It can't reach here, can't reach here. Or this one is specifically dark, so this one has to be medium. We also have to reach a 5. And we can only be 2. So it's either 1, 2 or 1, 2. And one of these is a 5. So this cannot be 5. So the medium gray needs an access to a 5. It's either here or here. Therefore, this is dark here. And it cannot be 8. This is a region here, region border here. We need access for the dark to a 3. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. It technically could reach here. But then that would... Okay, so then that would block off... Okay, yeah. 3 can... It would have to go here if that were the case. And then this 3 would not be in a region at all. So this has to be dark also. And a 3. We need access to a 2. 2 cannot be anywhere else here. because we have a 2 in each of these rows. So this in this dark then has to access this 2. So that's 1, 2, 3, 4, 5, 6, 7, 8. We have one more dark somewhere. Orange has to be either here and here or here and here. So this is orange no matter what. This could be orange or dark. This could also be green here. Any of these could be dark. One of these two is medium gray. This can be, actually both of these could be light. These could technically be light. So orange is essentially up to here. Dark can reach one more. The rest are green and lights. Okay, so light cannot go here. Light cannot go here. It can't go here because that would make green essentially a very small region. Same here. Can't block here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 at minimum, so this can't be light. Light could reach here. So this green is 1, 2, 3, 4, 5. Could be 6, 7, 8, and 9. Or 6, 7, 8, and 9. Either way. Okay. Let's see. One of these is a 5. One of these is a 5. There cannot be repeats in this cage. What else do we have in row 4? It's 5 through 9. This is 5 through 9. This cannot be 7. The remaining digits in column 7 are 2, 5, 6, 8, 9. And this can't be 9 either of these spots. One of these two digits is a 6. We're not sure which. This can't be 2 or 4 because of the 2-4 pair in the column. This can't be 1, 2, or 4, so this is 3, 5, 6, 7, 8, and 9 as possibilities. What else do we have here? The green needs access to 3 and 4. Okay, what can this digit... This can't be 1 or 2. None of this cage can be 1 or 2. We have a 5, 6, 7, 8, 9 quintuplet in this cage, which eliminates 5, 6, 7, 8, 9 in the rest of this cage. Therefore, this can't be 5, 6, 7, 8, 9. It must be a 4. The 4 cannot be... This is 4. This can't be 1 or 2. This has to be a 3 then, because the 5, 6, 7, 8, 9 eliminates 5, 6, 7, 8, 9 in the rest of the cage. The 4 cannot be part of orange or dark. It has to be green. So this is green, which forces this to be green. Therefore, the rest of this must be green, which means this cannot be green. This is light. This cannot be 3. This cannot be 2 here. We have 5, 6, 7, 8, and 9 remaining. One of these two is a 5, because 5 cannot be here in either of these cases. So 5 cannot be here. 9 has to be one of these 3 digits. This 3 and 4 are here. One of these is a 5, therefore this cannot be 5 here in this cage. This 4 eliminates 4 here. The 7, 9 pair eliminates 7 and 9 in the rest of the column. Therefore, this is an 8, which means this can't be 8. This can't be 8. So this is a region. This orange has to have another digit, so this can't be dark. This is orange. This orange cannot contain 6 or 7 or 5, so this has to be an 8, 9 pair, which makes this an 8, this is a 9. This 8, 9 pair eliminates 8 and 9 here, so this is 6, so this cannot be yellow, which means it's part of pink. Therefore, this must be then yellow here. And it cannot contain a 6. This 6 and 9 eliminates 6 and 9 here, so this is 2. This 2 and 6 eliminates 2 and 6 here, so this is 5. We have a 6, 7, 6, 7 pair in row 9. That leaves us with 2, 3, and 4 here. And 3 cannot be here. Where is the 3 in row 9? It has to be here. So this can't be 3. This is 2. This can't be 2. It's a 1 or 3. This can't be 2 either. We have 6 yellows. This can't be 6 because of the 6 in the row. This 3 eliminates 3 here, so this is 1, 3. This 1 eliminates 1 here, so this is 5 and 1. 5 cannot be this digit, so where is the 5 in this row? Row 3, it has to be here. The gray can only get access to that 5, so therefore these are both gray. This cannot be gray anymore because we have already 9 in size. So it has to go here as a boundary. This can't be 2. This can't be 2. We need an 8 in this medium gray region, so this is an 8. That 8 eliminates 8 here, so this is a 9. This can't be 8 or 9. This can't be 8 or 9 in the cage. So this 9... This 9 eliminates 9 here, so this is an 8. Which means none of these can be 8. This can't be 5 because... So how does this light gray connect? It has to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are all light. And therefore this can't be light here. We have all the regions now. So this cannot be 9. This can't be 9. This 6, 7 pair eliminates 6 and 7 in the rest of the row. And it can't be 9, so this must be 5. This can't be 5, 6, or 7, so this is 8, which makes that a 5. None of these can be 8 here. This 6, 7 pair eliminates 6 and 7 in the rest of the dark region, so it must be 9 here, which makes this 7. None of these can be 7. This 9 eliminates 9 here. We have a 6, 7 pair in the column, which eliminates 6 and 7 in the column, so this must be 4, which makes this 2, which makes that 4, which makes that a 2. This can't be 2, 4, or 7, so this is 8. So 8 cannot be here. We have a 6, 7, 6, 7 pair, which eliminates 6 and 7 in the rest of row 8, so this must be a 4. The 4 cannot be part of red, so this is yellow. We have 1, 2, 3, 4, 5, 6, 7. Cannot connect to here, so this cannot be yellow, therefore both of these are red. The 4 cannot be here. Oops, cannot be here. Okay. We have a 6, 7, 6, 7 pair in column 2, which eliminates 6, 7 in the rest of the column. So this is 9, this is 8, this is 7, which makes this 6, this 7. So this cannot be red because the red has to go down here. Therefore, this must be yellow. This has to be a 9 and therefore can't be red. So this is part of yellow. This can't be yellow. This is part of red. We have all the regions now. This can't be 7, so this is 6, which makes this 7, which makes this 6, 7, 6, 7, 6, 7. This 9 eliminates 9 here, so it's 6 and 9. This can't be 7 or 9, so this is 6, and this must be a 7. And that's how you solve it. Yeah, pretty straightforward. Fairly easy for a chaos construction rule set. We were given essentially all the upper left corners of the regions from the start. And then the cages really restricted things a lot. So, yeah. But I like chaos constructions because it's interesting logic, and then also on top of that, I get to color. So, it's always kind of fun. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.